Hello everyone. I'm Ryan Ramon from Group 4, and today me and my team going to present about Marcet boiler from experiment 1. Our group consists of me, myself, Ryan, uh, Batrisha, Arunan, and also Muhammad Alip. Alright, so I'm going to start from introduction. So the introduction for this experiment is this experiment one is to observe the relationship between the pressure and temperature for saturated steam. This experiment use a Marcet boiler which going to heat up the water inside the boiler and measure the pressure while showing the temperature of the saturated water. So the theory and working principle for this experiment is the thermodynamic properties of a pure substance could be determined by two of the following characteristics: temperature T, pressure, heat S and V, and etc. Data characteristics could be obtained either from experiment or equations or using certain and among two thermodynamic properties that easily measured are T and P. Relations between these properties could be expressed in the form of graph or equation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Batrisha binti Abdurrahim and I will be explaining about experimental setup for experiment 1. So, as you can see there in the figure, we have manometer at the top of the boiler and the left side of the boiler we have a box that consists of temperature gauge, heater switch and master switch. And moving to the boiler part, which is the main part of this experiment, we have safety valve, temperature sensor, overflow valve, boiler with the insulating jacket, and drain valve. And the most important thing also in this experiment is water. So that's all for experimental setup. Alright, for methodology, the first step that you have to do is fill water into the boiler by opening the filler plug. Make sure the overflow valve is open because we want to let the water flow out from there when the boiler is full. And close the filler plug back. Next step is heat the water in the boiler with the overflow valves is still open. When the temperature reach about 97 degrees Celsius to 100 degrees Celsius, immediately close the overflow valve. Step 4. Note the increase in temperature for each pressure of zero point 0.5 bar until the pressure reach 5 bar. After that, switch off the heating and record the decrease in temperature for each pressure of zero point 0.5 bar. And lastly, record the results obtained in table 3.11.
Alright, next we proceed to the result. As you can see, we have the table that has gauge pressure, absolute pressure, steam temperature for increasing, decreasing and mean, measure slope and calculated slope. So for the absolute pressure, we just add 1 bar from the gauge pressure, and mean we can get from sum up the increasing and decreasing and then divided by 2. Next table is table for specific volume and also specific enthalpy for this absolute pressure of the water. So here we have two graph, which is heating process and cooling process graph. So both graphs show that the temperature increase as the pressure decrease and the temperature decrease as the pressure decrease. For the next calculation, which is the temperature times with specific volume divide by specific enthalpy. So the unit for temperature is mass in Kelvin. So we must add 1273 into the formula, and then for the unit Kelvin over kilopascal, we must time for the specific enthalpy we must time for by 1 kilojoule per kilopascal. Next, for the measure slope. So for example, we take the measure slope at the tuba. So the formula is the mean temperature at the tuba minus mean temperature at previous pressure over pressure minus previous pressure times 100 kilopascal over bar. So we substitute the formula and then we get 0.166 kilo Kelvin over kilopascal. For the percentage error, we have modulus measure slope minus calculated slope over measure slope. So substitute the formula, substitute the value, and then you can get the value must not exceed 10% to make sure that your experiment is successful.
So for safety procedures, firstly, wear appropriate PPE, including safety goggles, gloves, and a lab coat to protect against potential splashes or hot water or steam. Second is be cautious around the Marcet boiler when it is in operation, as its surface and component can become very hot. So even from the data that we've obtained, we could see that the temperature has risen to 155 degrees. Then ensure the overflow valve is open while filling water into the boiler. This prevents pressure building up during the filling process. Avoid overfilling to prevent water spillage and ensure safety of operation. Always open and close valves slowly to prevent sudden pressure changes that may damage the boiler or cause injury. Continuously monitor and pressure and temperature using a manometer and temperature gauge. Do not exceed the maximum operating pressure, which is 5 bar in this experiment. Confirm that the safety valve is functioning properly before starting the experiment. This is critical to release excess pressure safely. And during heating, keep the overflow valve open until the water reaches a temperature of 97 to 100 degrees. Close the overflow valve only after this temperature is reached. Switch off the heater before recording the decrease in temperature and pressure. Allow the boiler to cool down naturally before handling it further. Avoid standing directly over the boiler while it is operating to minimize exposure to steam release. And finally, keep the working area dry to prevent slips or electrical hazards from spilled water. Thank you.
For the discussion, so we have three answers, which is the aim of this experiment is to determine the relationship between pressure and temperature before experiment is carried out. The reading temperature of the water is at room temperature while pressure is zero. So from the curve in both graph 1 and 2, the temperature increase as the pressure increase and also the temperature decrease when the pressure decrease after we switch off the heater. This means that the temperature and pressure are dependent on each other. This can be seen or proved from the plotted graph that show the temperature are directly proportional with the pressure. That's all from me. Thank you.
So, for the conclusion, our experiment successfully demonstrated the relationship between pressure and temperature for saturated steam. It was observed that as the pressure increased, the temperature of the saturated steam also increased, which aligns with our thermodynamic principle governing phase equilibrium. And as the results confirm the theoretical prediction of the pressure temperature relationship, as indicated by the plotted graphs in the result section, and additionally, the experimentally determined slope for dt, which is delta temperature, over dp, delta pressure, closely match the theoretical value derived from the Clapeyron equation, validating the accuracy of the data and the methodology employed. Thank you.